Hi, welcome everybody. This is going to be your notes for lesson on 4-1, which is the graphs of sine and cosine functions. So let's talk about this. And as we go through it, I'm going to do my best here to make some clear graphs, but it's going to be kind of difficult with this stylus that I'm using today. So, as we go through this, we're going to start by graphing sines and cosines, which you already did, but you did them with those little papers that you did the other day, and then the big butcher board papers that you kind of created your graphs. So we'll start with just sine, so graphing y equals sine x. So your table that you have here is like a normal table you'd have in algebra with an x and a y. On the left side is your x, and on the right side is your y, but in this case the x is going to be degree measures, and your y is going to be the value of whatever sine is. So if you're thinking about the unit circle here, and you think about your starting spot, which is usually right there, which is like this spot right here, which is an ordered pair of 1, 0. That's supposed to be 1, 0. You end up having a sine value of 0 when your degree measure is 0. We'll get to radians in a moment. So when you have your 45 degrees, which is going to be like up here, then you're going to have the square root of 2 over 2 as a value for the sine of 45. Now square root of 2 over 2 is also 0.7. We kind of went through that the other day. So that's around a decimal of 0.707. So that'll come into play later. And when you go up to 90 degrees, the sine of 90 is 1. 135 is also radical 2 over 2. 180 is going to be 0. 225 by using the unit circle is negative radical 2 over 2. And then 270 is negative 1, and then negative radical 2 over 2. And back to 360 is the same as 0, so you get 0. So if I was going to create this graph, my x value is 0, and my y value is 0, so that once again is the origin. Now when you're creating xy graphs, you're going x, 1, 2, 3, 4, etc. Y's are 1, 2, 3, 4, etc. on your y value. But on trig graphs, it's a little bit different. Your x values are going to be your degree measures. So when you go over 1 here, I'm counting by 45 degrees. So this 45 degree is this next value here. Erase that here. Okay, so when you do your second ordered pair, you've got 45 over, and then square root of 2 over 2. Now what about this y-axis values? Since the highest you go is 1, I'm going to call this here 1. So this one here in the second one is going to be like a mark of 0.5. So where would 0.707 be? 0.707 is going to be around here. And then when you move over to 90, you go up to 1. And when you go to 135, you come back down to around 0.707, and then 180 is going to be 0, and you complete this, what we like to call a cycle, and in a moment we're going to talk a little bit more detail about that. That's going to be a period. This here is negative 1, so I would go down to 0.707 here, which would be around here, and then negative 1, and back to 0.707, and then 0. Now, what happens when I have like a 1 degree angle, or a 2 degree angle, or a 44 degree angle? Well, this is a continuous function, so this cycle would continue with this same exact cycle. So if I change colors to red, and let's make the little tip of this thing a little bit smaller, so you don't erase these dots, you would have, whoops. Let's try to do this a little bit better. It's very difficult with a stylus. You'd have this cycle that looks like something like this. And if you go negative directions, you're going around the unit circle, so basically it would follow this same pattern till you get back to 360 in a reverse-like direction. This is your sine graph, y equals sine. Now when you move to cosine, it's a very similar thing, but just for fun here, I'm going to change all of these x values here to radians instead. And I know that a cosine, just like a sine, would complete one cycle when I get back to 2 pi. So, of course, thinking about the unit circle, something like this, you have this first starting point right there, and that first starting point for cosine is going to be 1, so I know at the end I got to get back to 1. So what happens at pi over 4? It's the same as sine, so square root of 2 over 2, and then pi over 2 is 0, and then 3 pi over 4 is negative square root of 2 over 2. Remember, negatives, all students take calculus, so in quadrant 2, you're going to have negative values. And then for pi, you get to negative 1, and then negative square root of 2 over 2 again. And remember, there are different pieces in between here, such as up here I also have like a pi over 6, and then I could also put a pi over 3, but I'm just going to do these to give you the general feel. And then after negative square root of 2 over 2, 3 pi over 2 is this point right there. That point is 0, negative 1, so the cosine is 0. And then, once again, radical 2 over 2. Now, when I produce this graph, it's going to be a little trickier. So I didn't put a scale on the x-axis on purpose. So I want to go to 2 pi. So how many am I going to count? I'm going to count a little differently because I made this scale a little differently. So I'm going to count every 2 is a pi over 4. So this first one I'm going to count as pi over 4 right there. This is very difficult here, but let me try to do the better job on this. So I'm going to count this as pi over 2. This right here is pi over 4, then pi over 2. Then 3 pi over 4 would be skipping and going here. And then this one is the key one. That's when you get fully around. That's a pi. I'm going to label that one. So pi. Pi would be right here in the middle of that one. And then, so that'd be 4 marks. So 1, 2. Try to make that better again. 1, 2, 1, 2, and 1, 2. So this will be my end of my cycle, 2 pi. So that gives me 8 dots. So I'm like skipping one. I'm going to make this a little bit wider. So I'm going to count up 4 to give me a value of, I'm going to count up 8 to give me a value of 1. So 1, 2, 3, 4. So this would be like half. 1, 2, 3, 4, and this would be like 1. So I'm going to label those. So 1, 2, 3, 4 on your y-axis, and these can be made to any scale you want, but if you know kind of how the unit circle works, it's not so bad. 1, 2, 3, 4, and here's another one that would be like negative 1. So 0, 1, I'm going to change colors here to blue. That is this point for cosine. And then pi over 4 is the first little line I've got, so I'm skipping one, so I got pi over 4 is that first red line. Square root of 2 over 2 is 0.707, so right about here. Pi over 2 is this line like right there, so that's going to be 0. And then 3 pi over 4 is negative square root of 2 over 2. So negative 0.7 is around here, and then negative 1 for pi, which would be here. And then you complete the cycle by ascending upwards. And then the last one is here, and then the last one would be 2 pi comma 1, which would be up here. Now this cycle looks a little different, but it has a similar feel to it. It looks like this. If I continued in the negative direction, I'd have the same basically pattern that would go like this. That's a cosine graph. Okay, so making the scale here is going to be one of your more challenging. So let's just talk about general vocabulary of all this stuff. So I'm going to start by talking about the vocabulary of a periodic graph. What is a periodic graph? I'm not going to write this all out because I'm having a hard enough time writing on this with this stylus as it is. So I'll just verbally tell you. A periodic graph is a graph that continues in a bunch of different cycles. Each of those cycles is called a period. That's why they're called periodic, because they kind of repeat the cycles. A period is the shortest amount of time it takes to complete one of those cycles. So for sine and cosine, and you can feel free to get these down, the period of sine and cosine is both 2 pi. Now that's the radian version of the period of sine and cosine, but in degrees, you would consider that 360 degrees on both of those. Tangent is going to be saved for another day because that's tricky. It's very similar, but it is different. And just, you know, a sine graph would look like this. This end here is going to be 2 pi radians, or 360 degrees, before it begins to repeat and give me a new cycle or period. Amplitude is the distance from the midline. Well, what's the midline? The midline is kind of, these graphs have these little bumps on them. So the midline for this one is going to be just the x-axis. And the amplitude is the distance from a peak to the midline. So in this case, you're going to be going up 1, so the amplitude is 1. Now a lot of this stuff changes depending on the graph. So as we move over to this one, we're going to slightly change our graph of sine because in the real world things don't fit sines and cosines perfectly. This one fits y equals 2 sine of theta. So I'm going to do the same thing here, and I'm going to do degrees, and I'm going to start with my little cycle of y values. So now let me do one of these and kind of show you how it works. So if I was going to do y equals 2 times the sine of 0, I need to figure out what the sine of 0 is. Now the sine of 0 according to the unit circle is 0. So 2 times 0 is 0. So that's how I figured out this ordered pair. That's not a difficult one. But if I do another one, I would go y equals sine of, I forgot my 2, 45. Okay, sorry, it's off the screen, it's a 45, but don't forget there's a little 2 there. So the sine of 45 is radical 2 over 2, and I multiply that by 2. These 2's cancel, so I get radical 2. Now radical 2, if I use a calculator, that's around 1.4. Okay, just for future reference when I'm about to graph that. 90, the sine of 90 is going to be 1. 1 times 2 is 2. So basically, I'm going to be taking all of those values of the regular sine graph, the y values, and multiplying them by 2. 135, again, is the square root of 2. 180, and you know what I suggest you do is I suggest you probably, since this is example 1, you'll need in your notes, so I'd suggest you maybe copy this one down and try to pause the video here and see if you can complete the table. 180 then becomes 0, negative radical 2. How did you do? And then negative 1 and negative radical 2, and then we get back to 0. Now this graph goes a little bit higher. Since the amplitude here is a 2 value, that means our highest value is going to be 2. So I'm going to call this 1 and this 2, and I have the freedom to adjust the scale. Now I'm going to try to get a good scale here to get to the end result of my graph. So let's see if I say that end here is 360. How many lines do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8, so 4. 1, 2, 3, 4 is going to be 180. Half of that is going to be where my 90 and my 270 are. So now I'm going to probably put a little scale on here, so I'm going to put like 180 by the middle, and then that'll just tell my person who's looking at this graph what I'm counting by. So I am counting by 45s each line, and every other line counts by 90s. So once again, 0, 0. And let me change colors here so you see really what's happening. So 0, 0. And then 45 over, which is one line. Square root of 2 is 1.4. You go to here, then you go to 90 and 2, 135 and back to like 1.4, and then 180, you go back down to 0, and then you go to around negative 1.4. Oops, 1.4 is down here. and then negative 2, back to 1.4, and back to 0. And you still have what we call a sinusoid graph, a graph that fits an equation with a sine value in it. And of course you could continue this later. See, the middle here is 4 lines over. 1, 2, 3, 4 lines over. And you get back, so you could probably do one of these things and just kind of make your best little graph. There you go, that's the graph of y equals sine 2 sine theta. And this graph. Let's try this one where the 2 is inside and not in the front. This is where things get tricky, and this is where I always struggle. So I'm going to do this one in radians, and this is going to be kind of tricky. So I'm going to put radians here so I know I'm counting by radians. I'll abbreviate it because I'm having a hard time writing with this stylus. And I'm going to start with the same things like 0, and let's do pi over 4. And let's do pi over 2 and see how this works. So now if I substitute a 0 in here, I still do not have a difficult thing to do. It's the sine of 2 times 0. 2 times 0 is 0. The sine of 0 is 0. Done. Unit circle. Let's do the pi over 4. Let me show you the work for that. Y equals sine of 2 times pi over 4. Now this is where it gets kind of tricky, because your order of operations tells you to do this first. 2 over 4 is 1/2, so this simplifies to pi over 2. So what is the sine of pi over 2? The sine of pi over 2 is 1. So even though I'm at pi over 4, I'm really at 1. Interesting. Changing colors. What happens if theta here wasn't 0, wasn't pi over 4, let's say it was pi over 2? So when I do pi over 2 times 2, the 2's cancel and I get pi. So now I need to figure out what the sine of pi is. The sine of pi is 0. Oh, this is very interesting. So let me just graph this cycle. 0, 0 is here. What should I count by? I'm still going to count by, this is pi over 4, and this is pi over 2. Let me just put one of these in there, pi over 2. And this is 3 pi over 4, this is pi, and then 1, 2, 3, 4, and then this end here is 2 pi. Okay? So now if I start with 0, 0, let's go to green, and I go pi over 4 up to 1, I'm going to count this as 1. I can change the scale every time I want to. This is negative 1. So at pi over 4, I'm at 1. And then I come back down to 0. Can you make a prediction of how this will continue on, knowing what you know about sine graphs once you get a few of these? Let's try one. How about pi? Now pi is way over here. My guess is it's going to kind of come down because I think that I got to complete this cycle. Let's see if I'm right on that matter. So I go y equals sine of 2 times pi. Well, what's the sine of 2 pi? The sine of 2 pi is 0, so I didn't quite do that right. So let me erase this. And the sine of pi is back to 0, so I needed to go down here to here. This is a cycle. Very interesting. That is one period. Now I could continue this on if I wanted to, and it would look like this. So then to get to 2 pi, that'd be 2 periods. And then I could keep going this way if I wanted to, because I know my pattern now. 3 periods, etc. Very interesting. So basically you're comparing this graph. I'd like you to write a sentence in your notebook about the difference and the similarities between y equals 2 sine theta and y equals sine of 2 theta. Try to use some good words with period, amplitude, things like that. I suggest you pause the video, write this down in your notebook, and then continue on. We will go through the answers to these questions in class. Now I'm going to have you finish up here with doing example 3, 4, and 5, and I'm going to start you with 3. But I will want to give you a formula here to get you going. The formula to figure out a period of a sine or cosine is 2 pi divided by b if you're doing radians, or 360 divided by b if you're doing degrees. What is this b we ask for? Well, the b is the number that goes inside here with the x. So in this case, it's x over 2, and in front of the x is a 1, so my b is 1/2. So my period for this graph, right here, -4 sine of 1 over 2, is going to be 2 pi divided by 1/2, because 1/2 is my b. Now I can't divide by a fraction, so I can only multiply by the reciprocal. So 2 pi times 2 is 4 pi. So my period's going to be 4 pi. It often helps to know what the period is before you create your graph, because then you know that on this x-axis here, you're going to need to go all the way to 4 pi. I'm going to get this graph started for you, and then I'm going to ask you to finish it for class for next time, and then I'm going to get you started on another one. So basically, it always helps to pretty much make a little table in your mind to at least get the feeling of what's happening. I like to figure out where, because if you think about a circle's breaking up the unit circle into 4 quadrants. So once I get the period, I know that my cycle will be completed at 4 pi. So half of my cycle in this case is going to be 2 pi. And then I like to do half of that too, because that would give me 4 different data points. Half between 0 and 2 pi is going to be pi, and between 2 and 4 is going to be 3 pi. Let me change colors here so I can put some lines in my table. And now, once again, I'm going to try and figure this out. So if I substitute a 0 in there, just listen to me verbally because I'm running out of room. 0 over 2 is 0. Then I do the sine of 0. The sine of 0 is 0. Then I do 0 times -4, which is 0. So 0, 0 is going to be a point. Now I'm going to complete a cycle in 4 pi, so I'm going to skip every one, I think. So I'm going to call this right here pi, this right here 2 pi, and I'll label that one so I can see my labeling. I'm going to count this right here 3 pi, but I'm not going to label it because it's going to get too busy on my graph. Let me make that a little bit clearer. Okay, so 3 pi would be there, and then 4 pi will be there. So I'm going to complete a cycle from here, the beginning, to there. So then I got my 0, 0 point. Now I'm going to try to do my pi point. So I'm going to substitute a pi there. I'd get pi over 2. The sine of pi over 2 is going to be 1. So this answer is 1. What's 1 times a -4? -4. Ooh, interesting. Thank God I didn't put a scale on my y-axis yet. So I'm going to count each of these as half. So this is going to be -1, -2, -3, -4 right there. I'll label that one so my teacher or I understand what I'm counting by. It's a -4. This will be easier with a pencil. So I'm going to move over to pi, and I'm going to go down to -4. Interesting. So now the sign goes down instead of up. I wonder why that is. All right, let's do 2 pi. I'm going to do one more. So I'm going to plug, I'll do this in yellow, 2 pi right there. So what's 2 pi divided by 2? The 2's cancel, it's just a pi. What is the sine of pi? The sine of pi is 0. 0 times 4 is 0. So then I get this. I'm going to have you continue this graph for 2 periods of a function. I got one of them started for you, and I'll let you go. Now here's how I'd like you to finish it. I'd like you to finish it by trying to finish example 3. I'd also like you to attempt to do example 4, which is right here. So finish graph 3, and I'm not telling you anything about number 4 until next class. And then I'm going to see if you can label this and sketch it. Now just a couple things about drawing graphs like this in your notebook. The way I would do it would be like this. I would just make a really long horizontal line, and that would be my x-axis, which represents degrees or radians. We did a couple degree examples. Let's try to stick with radians from now on. And then a shorter y-axis, and that's going to be the value of whatever this result is. I would also recommend in your notebook you put a table, and then you put some key points, and don't forget your period is going to be 2 pi divided by b, and that b would help you because in this case it's -4. Okay, and period technically is absolute value, so you're going to get a negative for this one, but period is a length, so it's going to be a positive number, so kind of ignore the negative. All right, and that's all you need to do for next class. Thanks for listening.